In this whiteboard video, I will be explaining how merge sort works. Given a list of input elements, in our case numbers or integers, how do we go about sorting this list of numbers so that we get them in a sorted order? So in this case, as you can see, the numbers are 10, 500, 1, 10,000, and our output we want in increasing order, which will be 1, 5, 10, 100, 10,000. So what basically does merge sort do? Merge sort works by the principle of divide and conquer. What do you mean by divide and conquer? Divide and conquer means that we actually divide the given list in by two into two halves, and then apply merge sort on the individual two halves. And not only that, for huge lists, like this is like 5 elements, but suppose you have 500 or 5,000 elements. In that case, you will keep on dividing. Before proceeding any further, let us see how the dividing works. So as you see, I have divided this 5-member list into two lists of 2 members and 3 members. Now this 2-member list will be our first object of attention. So how it works is, it takes up, as I said, each individual sublist and then applies merge sort to it. So as we saw, there are two sublists. Now we will take the first sublist of 10 and 5, and then we again apply merge sort algorithm to it. So as you see, we have 10 and 5. Now we break it up into 2 again. So we get nothing but 2 sub arrays of 1 element each, 10 and 5. Next we apply the second half of the divide and conquer merge sort algorithm. So first half was dividing, and now we have to conquer. And what do you mean by conquer? It's just a general term, but what I mean is, now this sublist of 10 and another sublist of 5, now they will be merged. And when do we decide that we have to stop breaking or dividing and start merging? When we reach the element size of 1. So in this case, if you see, both left and right side sublists are of size 1, so we proceed with merge. So as you can see, the merging algorithm would take 10 and 5 and put them in the correct order. So as you know, 5 is less than 10. So these elements will have their places interchanged, and what we will get is a sublist with 5 and 10, and we will say that this sublist is now sorted. One important thing to understand at this point is that when we call merge sort on the first sublist of 10 and 5, we called it recursively, as in the sense that the sorting algorithm calls itself again. This you can understand more when we see the code, but for now you can understand that every individual broken up sublist which we get will be broken down again until it reaches the size of 1, as we saw in the case of 10 and 5. Okay, now let's proceed forward. Our next sublist is 10, 1, 10,000. Now let's break it up into smaller ones, smaller lists. So first sublist will have 1 element, and the second sublist will have 2 elements. The way to arrive at how many elements to place in each sublist is simple. You take the total number of elements in the list. In this case, there are 3 elements, 100, 1, 10,000. And we divide it by 2, because you have to divide in 2 parts. So 3 by 2, 1.5. We round it off to 1. And so our left hand side sublist has 1 element, 100. And our right hand side sublist has 2 elements, 1 and 10,000. So as we saw earlier, now 100 is fine. 100 is the bottommost we go in the recursive tree. You can imagine it as a tree of data. And in the case of the second one, 1 and 10,000, it's still of size 2. So it will still be need to be broken up into two elements, 1 and 10,000. So as you can see, this will be broken up again into 1 and 10,000. 100 comes down as it is because 100 is already a single sized array. So now we are broken up. And as you can see, 1 and 10,000 when we merge together, and as I said, 100 is sorted sublist. So 1 and 10,000 when they are merged together, they will be placed in an order which will be 1 and 10,000 because 1 is smaller than 10,000. So now we have two sorted sublists, one with two elements, one with a single element. So our next task is to now merge the two sorted sublists. So these three values together will now need to be sorted. So at this point, I would like to briefly tell you something which I will explain more in the code which follows this whiteboard video, that the logic for merging of two lists simply involves picking up the least value from the left and the right sublist and then proceeding ahead picking up the next least value. So given the two sublists, when we merge the two sublists, in this case with values 100, 1 and 10,000, we'll pick up the smallest one 1, then we'll pick up 100 and then we'll pick up 10,000. And the thing which makes this algorithm more efficient is that each sublist is sorted. So if you see 1 and 10,000 is sorted, 100 is sorted. So if you had say 100 elements on the left side and 101 elements on the right side, or maybe even more, in that case, once you exhaust one of the sublists, the other sublist which is in sorted order can be directly appended to the merge list. So for example, when you have in this one you have 1 and you have 100, then you pick up 100. So the remaining elements, because the left side is exhausted, the remaining element in case if there is only one, that is 10,000, will directly be pushed into the merged array. So 100, 10,000. If after 10,000 you had 10,001, 10,002, once you pick up 1 and then you pick up 100, your left sublist is exhausted. So whatever elements you had after 10,000, in case I'm saying assume if you had more 10,001, 10,002, all those will be in sorted order and they can be directly pushed into the final merged list. So now we are calling merge here and we should get 1, 100, 10,000 as I just explained the merging part. So this is a sorted sublist. Remember we had broken down our original list into two lists. One had two numbers, other had three numbers. So now we have both those portions sorted. We have two sorted sublists, one of size 2, another of size 3. Now we need to merge these two sorted sublists by picking up elements in the increasing order from these two lists taken together. So I will show you in detail in the code part which follows how to actually pick up elements from both the lists which are the least. For now you can see the least one at the moment is 1, then you have 5, then you have 10, then you have 100 and then you have 10,000. So this is our fully sorted list, final sorted list. You can check out the whole process here. So if you see on the left side, the left sublist was handled, and on the right side, the right sublist of 100, 1 and 10,000 was handled. And eventually, we got sorted sublists of the left side and the right side, which finally led to the final sorted list. Next, I will be explaining the code, Java code, basically for the merge sort algorithm, how to write code which brings this algorithm to life, so that any number of elements you pass to that recursive merge sort algorithm, it will be able to break it down, divide it down into the single unit size elements, and then keep on merging them upwards till you get the original list back again, but in sorted order. So let me jump over to my IntelliJ idea ID next. As we saw in the whiteboard video, that merge sort is all about divide and conquer. One needs to divide the given list of elements and then recursively keep on dividing them in order to arrive at a single element beyond which we will stop the recursion, or that is the recursion limit. Once we have single elements, then we climb upwards in the recursion tree, wherein we start combining the single elements and then keep on merging upwards till we get the original array back. So as you have seen in the whiteboard video how the recursion was used for accomplishing merge sort, let us now see the code for merge sort. In this code, I will show you how recursion is obtained and how a given list is sorted using merge sort. So I have a list of elements, static input array, which is 5 elements, which you saw in the whiteboard video also. Next, I have my main method in which I say arrays before sorting. I print the input array and then I say do merge sort on the input array. Now, what does do merge sort do? Let's get down to it. As we saw in the whiteboard video, the given list needs to be divided into two parts recursively. So our do merge sort method does exactly that. It takes a int array as input. The array is named values, and it finds out the middle point of the array. So values.length by 2 is the gives us the middle point. Then it initializes two arrays, left and right, which are nothing but the left portion and the right portion holders. The left portion has exactly mid number of elements and the right portion has length minus mid number. You see a values dot length less than equal to 1. I will come back to this later. So now that we have created holders for left and right arrays, we need to now populate them with values. So the values array has the list of elements we need to populate into left and right, and we iterate inside the values array and fill up the left array till it reaches the mid, and then beyond mid we fill it into the right array. So now we have two portions of the input array with us. Next, what do we do? Next, as you saw in the whiteboard video, we need to merge the left and the right part. But as you saw there, we don't start directly merging the left and the right portions. Instead, we call the merging algorithm again on the left portion and the right portion. So this is the recursive call. So this is the recursive call. As you see, do merge sort method is calling do merge sort of the left and do merge sort of the right. So given that you have say 1000 elements in your array, this point here you will call do merge sort on the first 500 elements, and you will call do merge sort on the second 500 elements. So in effect, what you are doing is your call to merge 1000 elements is internally calling two times itself to merge 500 and 500 elements. So, and remember, we keep breaking up the list to be sorted in this way. Until when does this breaking up go on? We need a boundary condition, right, in order to stop the recursion. Otherwise, it would become infinite. So the boundary condition is that the length of the input values array is 1. So if the length of the input values array is 1 or less than 1, but it will stop at 1, we know that, because we won't allow it to go below 1 itself. We will return here that array back. So an array with one element will not be further divided into two arrays, left and right. It will be returned as it is, as you saw in the whiteboard video also. Okay, so now one part is clear. We keep on recursively dividing and then we arrive at single elements. Now, once you have reached single elements, you reach the bottom part where the two arrays which are to be merged are all single element arrays. At that point, we merge them. Okay, so this is why we are calling merge here. So when you have a two element array here and a one element array here, then this guy goes and it calls values with two element array, which breaks up into two arrays of one element and one element. So in effect, this merge will work on one element and one element ultimately for all the elements at the bottommost part of the recursion. So how does the merge work? So we merge upwards, right? I showed you in the whiteboard video, we keep merging upwards into bigger and bigger size. The way we broke it down and we reached single elements, the same way we keep merging single elements and going upwards, we keep the size of the arrays being merged, keep increasing, and we finally reach the original size again. So this is the push into the stack, recursive stack. And now once we reach the single element, our pushing will stop and we will start doing popping. So the first pop is of one element array each. And if you now come to the merge method, where the merge is our place where we do the logic once we pop. And then, so if you see, it says merged is equal to new int left dot length plus right dot length. So when you get one element each, you get a new array of two elements. And then this is the most important part, the merging logic. So you take each element of the left array and you keep going forward, adding elements to the so you are basically going to iterate over two arrays, the left array and the right array, and you need to have elements in the merged array in the correct sorted order. Now to do that, you will have a new array known as merged array. Now what is merged array? Merged array is nothing but a combination of what we defined here a little while back. I was telling you we have a merged array which is a sum of the lengths of the left and right array, and we keep populating the merged array with the left counter till left is less than or equal to right. Next, what we do is if left is not less than or equal to right, then that means right is smaller. Then we put right and we increment the counter of right. When we are putting in the left, we were incrementing the counter for left. So we keep consuming elements from the left and the right array and keep incrementing the merge counter, which is the merged arrays counter, And at the end, when we exhaust left array and right array, and all the elements are put in the merged array, they will be in the correct order because of this logic. The next lesser element always goes into the merged array, or the least element among the left and right array elements remaining to be put in the merged array goes into the merged array. So not in all cases you will have the lengths of the left and the right arrays equal. In case your left array has all elements which are greater than the right array, so your right counter will get over first, and you will come out of this while loop. So you need to populate all the elements of left which will be in sorted order, because remember, the left and the right are sorted and then only given upwards. So now you finish off the remaining of the left and you finish off the remaining of the right. Generally it will be only one of these two whiles which will be called, and because the end condition is that one of these two will be over, only then we will exit. So once you are done with the left counter and the right counter, and one more thing, as you must have guessed by now, for a particular list of elements, either the left counter will be empty or the right counter will be exhausted, rather not empty, because the exit condition is that one of the two should have gotten exhausted. After that we will come to this part. So now we have a list of all the merged elements in the correct sorting order because of this logic we have done. So when we called merge, okay, so we kept breaking down the array into multiple smaller arrays till they were an array of length 1. Then we started merging them together. Recursively, it kept on moving upwards. And then as they kept on getting added, they were put in the correct order. And finally, you have a correctly sorted array as per the merge sort algorithm. And then you have the elements finally in the correct order. That is the sorted order. This is exactly what we saw in the whiteboard video. In case you have any doubt still of how the recursive calls work, you can see the video once more and see how I have gone down the left and right arrays recursively till we reach the size of 1. Okay, so that is merge sort. If you have any queries, please feel free to comment in the comment section. I would be happy to answer all your queries. And if you like the way I made the whiteboard video and like the way I explained the code, then please do like and share this video. Thank you.